guys, my name's Rebecca.
I'm Skylar.
And my name's Nicole, and we are going to explain to you about how we made our rocket explosion. Mr. Morris, this one's for you.
Alright, so our job was to create a rocket with a 2-liter bottle of soda and other materials such as a garbage bag, string, tape, scissors, and a folder to see how long it could stay airborne.
So for our first experiment, we tested descent time versus parachute size. Our hypothesis was that with a larger diameter of a parachute, the rocket would have a longer descent time. For our first trial, we used a parachute size of 17.5 centimeters, and the descent time was 1.21 seconds. For our second trial, we used a 30 centimeter parachute, and our descent time was 1.96 seconds. We continued on this route and found that as the parachute size increased, so did the descent time. We found that the parachute that worked best was the 61 centimeter parachute. For all of these trials, the lengths of the strings were constant, which explains why the 76 centimeter one did not work. Our theory is that the strings were too short to support that big of a parachute size. We also learned from this experiment that glue was a better medium than tape for securing the strings to the parachute and to the bottle.
As a side note, we're going to space because get it like rocket, play on words, space.
Okay, just while Skylar's building her ascent chart, we just wanted to explain to the class and Mr. Morris that we are dressed in tinfoil because we really wanted to give that extra that we wanted like on point because, you know, we have to.
We're aliens.
I don't know, bye.
In our second experiment, we tested the effect of adding a cone to the top of the bottle in order to decrease air resistance, resulting in a greater height and therefore longer air time. We recorded the time it took to reach its maximum height and then used the formula delta y equals 1/2 gt squared to calculate the height. With the cone, the bottle reached 10 meters, and without the cone, it reached 8.5 meters. We therefore concluded that with the cone, our rocket would have a more successful launch.
After our 2 experiments, we concluded that the 60 centimeter parachute and the utilization of a cone would make our rocket successful. We also increased the length of the strings to 61 centimeters. The 60 centimeter parachute allowed for the descent time to increase because its surface area and air resistance were directly proportional, so as the surface area increased, so did the air resistance, and a longer air time was achieved. The longer strings were necessary to support the larger parachute. All of these components played a role in making our rocket a success.
This is a little animation of what our rocket launch looked like.
This is what our rocket launch really looked like.
Yeah, it worked well.
Oh yeah.
Get to the ground.
Our official launch time was 5.95 seconds.
If we could change anything about our rocket, we would add wings to the 2-liter soda bottle so the rocket would be able to go vertically up, creating a higher time that it is in the air, and the rocket would land vertically downward so that it doesn't land in a tree or it gets stuck by anything. It has like a straight path.
Hello and welcome to Rebecca and Nicole's Rocket Explosion.
Skylar, are you kidding?
What?
You forgot Skylar. We're only in her house.
Oh.
My crown stuff. Get it, guys? We're in space.
Because
Because
it's a rocket.
we build rockets.
Billy, this one's for you.
You owe me $5. Goose Jack, you owe me $5.
Five.
Rebecca, who's rocket one?
$5.
Who's
$5
Zila?
rocket launch.
Oh my god. Hello. Welcome to our video.
I can't do this.
I'm Nicole.
I'm Skylar.
And we're going to teach you about our rocket that we built.
It's called the Rocket Explosion.
Yeah, it is. Okay, longer. Sorry, cut that out.
Yeah.
Our hypothesis was that with a bigger...
I can't take you seriously.
Do you want me to do it?
No, Okay. Parachute. Okay, I'm sorry. Sorry, Miss Morris. So,
For our next trial, oh god.
it's got